All right. Hello and welcome to Technically Speaking's episode 12 for 2025, our season recap and town hall. Thank you for all of those that have been with us throughout the last four seasons and are here with us to wrap up this fourth season. Super excited to bring you the recap today, but let's go ahead and get through some formalities before we get it underway. First and foremost, for anybody who is joining us for the first time, this is Technically Speaking. I am your host here, Brandon Burton, the Senior Principal of Industry Relations at Cotality and the Chair of ANSI IICRC Standards. And we use Technically Speaking as a venue to bring you very technical topics for the most part, but a lot of restoration business topics as well throughout the year. And this particular episode is a recap of everything that we discussed in 2025. So, a couple things here to get you acquainted if you're not familiar with the Goldcast webinar environment and how we use it here on Technically Speaking. Do note that we use the Q&A feature pretty heavily here on Technically Speaking. And throughout today's presentation, if you have any questions on anything related to what we're discussing, or really anything at large in the restoration space, drop those into the Q&A. And at the end of today's session, we will focus on those questions. In fact, today is kind of an expanded Q&A. That'll be a little bit shorter presentation and a longer Q&A. So any questions you've got that you want to hit in the open town hall session, drop those in at any point. You can drop them in now, you can drop them in throughout the presentation, and we'll use those in our Q&A session. And then last note here for housekeeping is those Q&A sessions are only available to live attendees. So if you're listening to this after it has been broadcast live, you're going to miss the Q&A, which is a huge part of Technically Speaking. So just a reminder, join us live and be here with the live presentations, and you get the benefit of that Q&A session. So with that, let's start our season 4 recap. In the very beginning of the year, back in January, the very first topic that we explored on Technically Speaking was a discussion on exploring water damage trends. It was a session where we dove into not only the trends that we're seeing in industry and some conversations on how that may impact restoration companies and the restoration community, but we also discussed kind of some strategies for your business and just how you should set aside time to make sure that you're investigating and assessing kind of the indicators that those trends come from. So I'm going to start with that and talk a little bit about that strategy, because that was one of the key takeaways in that episode. This is also a reminder, by the way, and I'll share the link with you at the end of the presentation. But all of these episodes, if I'm hitting on some things you'd like to dive deeper into, you can always email me. But you're also always welcome to revisit those recorded episodes, which are all housed on nextgearsolutions.com/webinars. And I'll share that link with you again at the end. I'll put it up on screen. But where we started this discussion was really talking about carving out time in your business to ensure that you're looking at industry trends and aware of where these trends originate, especially the sources that really run the highest potential to impact your business. And I kind of categorize these into three primary buckets: technology and education being one bucket, regulations and standards being another, and construction and materials being another. And we spent some time kind of diving into each of these. In technology and education, we talked a little bit about some of the advent of technology that we see in drying equipment, in remote monitoring and remote sensing, and kind of where those stand as an industry. I talked a little bit about the growth of remote monitoring being integrated into manufacturers' equipment, which is something that I think is going to have a huge impact on our industry long term. As the cost and the complexity of those tools continue to come down, it's becoming easier to incorporate than it is to not incorporate those systems into drying methodology. And eventually we'll hit a tipping point where you're going to have your drying equipment, for the most part, mostly represented by those systems already being integrated and on board, and the cost and barrier to entry into that space will become minute. And we're getting very close to that tipping point, especially with manufacturers like Legend Brands and Phoenix, you're really incorporating that right out of the gate into their technologies. In construction and materials, we spent some time exploring really the change in building materials that we've seen over the last couple of decades, where the cost of building materials is putting pressure on the construction industry. The speed of construction is putting pressure on the construction industry. And at the same time, kind of a pressure in the opposite direction for sustainability of those materials in light of what we see with weather events. And then last but not least, we took a look at regulations and standards and what was happening there. A lot has happened in that space in 2025, and a lot is on the horizon. We saw the release of the S700, which we'll talk about a little bit later today, for fire damage restoration, which should be having a significant impact on those of you that do fire and smoke restoration. It's wonderful to finally have an ANSI ICRC standard in that space. And we'll talk a little bit more about that later because we had a dedicated episode on that this last year. We're seeing the same beginning to emerge specifically with wildfire. And that's another kind of impact area, especially for those of you in Colorado and California or other states that are going to follow the lead of those states as they implement legislation that is currently being debated by both of those states that will have a direct impact on insurance coverage and policy related to insurance coverage for wildfire restoration, assessment, testing, and all of those things that kind of play into that space. Side note to that, by the way, released today, so you're getting this hot off the press, released today by the IICRC, the RIA, and CIRI, is a technical guide for the restoration of wildfire impacted structures. You should be seeing all kinds of press on that throughout the day today and through the coming weeks. So if you are in an area impacted by wildfire, you're dealing with some of the wildfire impact for the last 12 months, watch for that document. And if you haven't seen it posted anywhere and you're not getting your hands on it, send me an email. I will send you a copy of that document directly. I sat on the task force that developed that document. So industry development can be, or industry trends are something you can incorporate in your business as kind of the other side of the conversation, either proactively or reactively. We spent a lot of time in that episode talking about how to be proactive, how to do your intelligence collection, how to assess your business and understand how things impact your business directly, and even how to do some reconnaissance into those areas where there are trends and understand how to adapt your business to those upcoming trends. But spent the most time talking about how not to be reactive and kind of the opportunity cost that comes with being reactive to industry trends and not responding to those industry trends until they're impacting your business negatively, especially through liability and collections challenges, et cetera. So it's a good opportunity in that area. And again, kind of the main takeaway is, be proactive, look at what's happening in these three main buckets, because from my vantage point, at least from where I sit, these are the three primary areas that I see impact on business where you have an opportunity to truly be proactive. Kind of summarizing that conversation, we talked about some of the drivers that impact those industry trends through weather events, changes in construction methods, changes in technology and information. And some of that, we really took a deep dive into construction methods and what's happening with single family dwelling units versus multifamily dwelling units and how that's having an impact on restoration. So we took a pretty deep dive into that space. Also, obviously, the industry drivers that are driving some of those industry trends with carrier policies, service level agreements, and programs, things like that. Some of the things that are happening, like I said, right now with wildfire, with government regulations, and just the complexity and the severity of losses at large as we see changes to building materials and changes in weather. So good places to look to stay abreast of what's happening and what's impacting the future. Episode 2 took us down the technical road where we love to live, and technically speaking, we did a 3-part series this year on specialty drying. We started off in episode 2 with a look at class 4 drying and low evaporation material specifically. And really this episode was really geared on kind of bringing in some of the basics that we need to understand about what we call class 4 specialty or difficulty in drying situations. We took a review of vapor pressure and understanding its role in drying difficult materials. And in this episode, we called out that psychrometry or psychrometrics isn't just about taking a temperature and humidity reading in the air, documenting your grains per pound, putting that into the documentation and calling it a day, right? If you really want to have command of a drying environment, we need to really employ psychrometry or psychrometrics to its full potential, which means we need to, especially rather with difficult drying situations, understand that psychrometrics can be applied also to materials, which is what's being represented here in yellow on the screen. In blue, we see the traditional reading. We have a temperature of the air, we have a relative humidity of the air being plotted on a psychrometric chart. We run that over to the right-hand side, and we see that the air in this particular example has a vapor pressure of 0.3 inches of mercury. That's the partial pressure of the water vapor being forced onto the surrounding environment. What we learned here is that we can also take that reading of the material. And in this case, we had a material that was 60 degrees Fahrenheit. That's the yellow solid line. Assuming that material is wet or saturated, that would represent a 100% relative humidity. We plot that over to the left, and we see that in this case, the material has a partial pressure of about 0.52 inches of mercury. What we learned is that that means the material is drying, right? The vapor in the material is pressing out at a greater degree than the vapor in the air is pushing in. That means water is moving from high pressure to low pressure. And if this sounds like absolute Greek to you, watch that episode because it gave a good basic introduction into how to understand the vapor pressure associated with materials. However, we also took a deeper dive into that later in the year, and I'll share that with you here in just a minute as we go through our recap. As we went through that initial introduction into specialty drying, we also introduced kind of the concept of specialty drying systems or equipment that we would use for specialty drying. Generally speaking, we were talking about adaptations to our standard carpet dryer with higher pressure and higher volume, axial fans that are ductable, high pressure blowers, things like the Airwolf, Inject-to-Dry, and Dryforce, and why those were important for controlling interstitial spaces. Generally speaking, specialty drying application generally includes controlling these little microclimates that exist within the structure and not overlooking kind of the X-ray vision that we need to understand where water exists on surfaces where evaporation is occurring that do not have direct access to the air that we generally control, which is the accessible living space, right? That's where our air movement and dehumidification is kind of universally being applied. But those are often not the surfaces where evaporation needs to be managed. And they're generally, in specialty drying situations, not the surfaces where we need to focus on environmental control, controlling temperature, humidity, and circulation to promote evaporation from these hidden and trapped surfaces. And that's kind of a high-level overview of kind of the world of specialty drying, is understanding where these microclimates exist, how to access these climates, and how to control these climates. We also took a dive into the S500. We talked about some of the language in the S500 that gives us some information on what needs to be done in these specialty drying situations. First, it defines that these situations are where water is deeply held or bound, where we can have a significant absorption into low evaporation materials and assemblies, and permissive statements, the may statement in the S500 that says, as a restorer, you have permission to use specialty drying methods, that drying times will be longer, and that substantial vapor pressure differentials are your ally. And that's where we're going to focus. Moving out from this, in episode 3, we took kind of a break on the specialty drying, the first of 3 installments there this last year. And we took a look at the S700. We took a look at the document with a couple of special guests. Basically, this episode was an interview where I interviewed 2 of the subject matter experts that were involved in the S700 creation. One was John Pletcher, the vice chair of the consensus body and owner of RestoreTech. The other was a longtime friend of mine and industry icon, Cliff Zlotnick, that's been a part of the restoration industry and really specializing in fire and smoke restoration for more years than he probably wants to admit. He's been in that space for about as long as I've been alive. And basically, we walked through the S700 and understood not only what is the document, but where did it come from? Kind of what were the roots and the history, going all the way back into the days of the RIA, working through the FS1 and FS2 documents, and that culminating in the development of our first official ANSI standard for fire and smoke restoration, and that published this year. We dissected the document, kind of distilled it down to the workflow for fire damage restoration, what is standard of care, and all of these main buckets that kind of work through the workflow in fire and smoke restoration. This is not a core area of my area of expertise, so I'm not going to give a real deep summary of this other than to say that if you are involved in the fire and smoke restoration process, I would highly encourage that you take a look at that episode. And if you have not already, make sure you have access to the S700, that you review that document, and in particular, the should statements, the standard of care statements that document embodies. Season 4, we got back to the technical with Class 4. So this was the second installment. A couple of really, really good takeaways in this session. First and foremost, we took a very deep dive into understanding how to leverage vapor pressure differentials. This is the stuff that drying Godzillas are made of, right? Is understanding how to leverage your psychrometrics to not only ensure drying is happening, but to control the rate of drying from specialty materials. So this particular chart that I have up here on screen, I want to use this as one of our primary takeaways for today. For those that have seen this before, it's a great refresher. If you have not seen this, I'm going to give you the technical details behind this. First and foremost, this is a psychrometric chart. A psychrometric chart should be something that you're using on a regular basis as a restoration professional. I know we have apps that calculate grains for you and can take care of that side of the documentation, but that does not replace an active understanding of the relationship between temperature, humidity, vapor pressure, dew point, and humidity ratio, better known as grains per pound. The only way you see that relationship is by using a psychrometric chart. So I highly encourage that if you actively make decisions in restoration processes as a part of your scope of work and your daily activity, you should have a psychrometric chart somewhere on your desk, somewhere in your truck, somewhere that you look at it on a relatively routine basis and just understand how these properties interrelate and how making changes to the environment affects these areas of thermodynamics. It's only through doing that that you truly understand this relationship, by looking at it on a chart. So this is what this particular chart is depicting. And I'm going to kind of walk you through this. So use your eyeballs and kind of follow along on the chart as I describe it. So here in blue, we have what you would typically take as an atmospheric reading. We have a 70-degree temperature. You can see it at the bottom of the chart, and a blue line that goes straight up the chart. That whole line represents 70 degrees Fahrenheit. The bottom of the line is 70 degrees when it's bone dry, right? The bottom of the chart is dry air. The top of the chart is wet air. The top of the blue line, where it hits that curved white line, is the maximum amount of moisture that can be suspended using the energy present, the available sensible energy present at 70 degrees. In this particular case, our air is not dry and our air is not saturated. The curved blue line through the middle of the chart represents the 40% relative humidity for our example reading. Where those two lines cross, 70 degrees and 40% relative humidity, there's a dotted line that goes to the right. This is how we make a calculation on the psychrometric chart. The first calculation we make on the right-hand side is just above 40. That's the humidity ratio, or grains per pound of dry air. If we keep moving to the right, the next ruler that we see is the dew point temperature. This particular air mass has a dew point of about 44 degrees Fahrenheit. All the way to the far right-hand side, we see the vapor pressure. This is the expression of the partial pressure of water vapor. So just the pressure associated with the water vapor. It is 0.3 inches of mercury. You don't necessarily understand what 0.3 inches of mercury represents. You just need to know that that's a fixed and known quantity. Now let's take our attention away from the blue for a moment. Now let's look at the orange. 60 degrees Fahrenheit, if you look at that on the bottom of the psychrometric chart, there's a line that goes straight up from 60 degrees there. That reading is a reading that has been taken of the material itself, using a laser thermometer, using a contact probe, using a thermal imaging camera that has the capacity to pinpoint a specific spot temperature. However you've obtained it, that's a reading of the temperature of the material. Now, that whole line represents the temperature of that material. The bottom of the line would be the material if it contained no moisture, dry, completely oven dried. The top of the line represents the temperature of the material if it was fiber saturated. It had absorbed as much moisture as it can absorb, right? The fiber itself is thoroughly saturated. In this particular case, we assume that the material is saturated. This is the beginning of a drying process, and I want to know how well that material is going to dry given the conditions I measured in blue. So we go to the saturation point at the top. We follow the dotted line all the way to the left, and we see that the material has a vapor pressure of about 0.52 inches of mercury. What we learned from this is that the material will dry, right? It has a higher pressure than the pressure of the surrounding air I'm placing into contact with it. However, what we can do with a psychrometric chart is we can understand the impact of making a change. And here's the change that we explore with this particular example. Notice the green arrow that slides the orange line to the right. In this case, what's happening is we're warming the material to 85 degrees Fahrenheit. And here's the magic of vapor pressure. And this is the key takeaway. If the material is saturated, it will still yield the vapor pressure associated with the saturation point for that new temperature. So if I take that 60-degree material that was saturated and I raise it to 80 degrees, it's still saturated. Notice what happens to the vapor pressure. Warming the material temperature to 85 increases the vapor pressure to that green dotted line about 1.21 inches of mercury. A dramatic increase in the overall vapor pressure. That gives us a differential of 0.91 inches. It quadruples the differential in vapor pressure. So my drying rate will literally be 4 times greater. So the value here in understanding vapor pressure differentials, and the reason why I want to spend some time doing a deep dive in this particular takeaway, is because it has a huge impact in your ability to assess whether or not it is feasible, economical, and practical to make manipulations like this in your drying environment. If it yields a 4 times faster drying rate to raise the temperature of that 25 degrees, then I can assess how I would go about making that temperature increase by inserting warmer air into a cavity or whatever my application is going to be. If that's reasonable and practical, is a 4-time increase in my drying rate going to be beneficial? If so, then let's proceed with that drying decision for that material that may not have made progress in the last 24 hours, given the situation or the circumstance. We then got into some specific applications of how to do that. We took a look at some of the different drying systems, talked about managing the microclimates so that we can use elevated temperatures at a reasonable economical cost to the project, as opposed to raising the temperature of entire areas or spaces, especially when they're occupied. And we got into some examples using some specific equipment that is generally available in industry. We further walked into some of those examples by getting into hardwood floors as an example, and talked about elevating the temperature in the first foot above the floor, not in the entire room, and then using rescue mat systems or injected dry systems to deliver that air to the bottom of the floor through a vacuum system. Again, if this is something that is complete and total foreign language to you, highly encourage that you take a look at that episode because we took a really deep dive, particularly in hardwood floor applications for this particular application. Moving on to episode 5, we got into substructures. So we decided to go from there to beneath the structure and take a look at some of the drying challenges that exist with crawl spaces, with basements, anything that would be deemed as below grade. As we did that, we first defined what substructures were, right? And anything that would be deemed a below grade structure within the space. From there, we took a look at some of the unique variables that relate to below grade structure and how they would apply to our drying plan or overall project management strategy with those particular spaces. We talked about ventilation as an option, especially with an unoccupied space. We talked about dealing with bulk water, dealing with insulation and vapor barriers, and how to control evaporation and evaporative drying, and when to consider barrier replacement. This is one of the key takeaways that I'll focus on for this particular review and recap. One of the primary areas for those of you that deal with crawl spaces, especially dirt crawl spaces below structures like I do up here in the Pacific Northwest, one of the questions that I often get is, do you remove a vapor barrier when a crawl space is wet, especially thoroughly wetted? And do you replace that vapor barrier after you're done drying? And my response is no. I do remove the vapor barrier if I need to remove the vapor barrier because the vapor barrier is compromised. I have standing water above or below the vapor barrier, but that vapor barrier is replaced as soon as the bulk water has been removed and the crawl space is accessible for reinstallation. The reason for that is I'm not focused on drying the dirt. I'm focused on drying the structure. And the longer damp dirt is accessible to the atmosphere that I'm managing, the more difficult it is for me to focus on the structure. Having said that, I will ensure that we deal with the bulk water before we reinstall the vapor barrier, right? Get rid of the mud, get rid of the stuff that's going to require scuba gear for you to go back down and install the vapor barrier. But you don't need to return the dirt to a dry standard. Unless there is a drainage problem and that dirt doesn't have the capacity to drain, which would be an engineering problem with that structure. So there could be an exception in that case. But as long as that's not a unique circumstance with that particular project, the goal is not to return the dirt to a dry standard. The goal is to return the structure to a dry standard and let the earth beneath the dirt deal with the earth beneath the dirt, right? Moving forward from there, we also talked about monitoring in substructures. And one of the key takeaways I want to emphasize that we talked about in this episode was that you don't necessarily need to crawl a crawl space every day to get your monitoring data on a crawl space every day, right? You should be monitoring those materials on a daily basis as the S500 articulates. But if you're down there on day one, create some connection points, use some standard speaker wire and run that speaker wire out of the crawl space and monitor from there. Whether it's through the interior access to the crawl space or the exterior access to the crawl space. A couple of wood screws, a couple of ring terminals, and a speaker wire. And all you need to do is connect your instrument to the end of that speaker wire when you come back each day instead of having to crawl the crawl space. I spent a lot of time being the little guy that always got shoved in the crawl space because I fit. So I have a little animosity about having to crawl a crawl space when I don't have to. So this, to me, is a really good time-saving tip. It also helps with consistency because when you're monitoring as opposed to inspection, when you're monitoring, what's important is consistency in the location. You want to check the exact same way every day so that you ensure that any change in the value is really a change in moisture content, not a change in process. So this really helps ensure that you're checking that same exact spot on a regular basis if you use this tip. It'll save you a ton of time suiting up and getting down into a crawl space. And then we also talked about, just some of the summarizing of goals as it deals with substructures. Obviously, as with any project, the initial goal is always stopping migration absorption, and then eliminating any damaged material and substructures. That can very easily be damage to drywall with standing water, damage to insulation, either overhead or in cavities. Elimination of the barriers that prevent you from dealing with the bulk water and dealing with the evaporation of structural moisture. Then once the bulk water is removed, focus on the structure, right? Especially in a dirt crawl space. Once that bulk water has been addressed and the crawl space is dry enough to be accessible, focus on the structure and reinstall that barrier. And then never overlook the opportunity for open or combination drying. We spent some time dealing with that in that episode on substructure drying. We don't have time to dive real deep into that today, but way too often we overlook the value and the opportunity of good, heavy, forced ventilation in substructures and just how powerful and beneficial that can be. Now we roll on to episode 6. We're halfway through the year, and it's a good opportunity for me to remind you that if you have any questions on anything that we are covering here today or anything related to restoration at large, and you'd like me to address that in the town hall session at the end of today's presentation, please drop those questions into the Q&A. Drop them in early, drop them in often. I don't see any questions in the Q&A right now, so please drop those questions into the Q&A, and we will tackle those when we get to the end of today's presentation. Be the first to drop a question. Drop it in there now. So now we move on to episode 6. This was our third installment in the specialty drying series from this year's episodes. And in this particular one, we got a bit deeper into the systems themselves, into the equipment. We talked about dehumidification. We talked about airflow. We talked about filtration devices specifically. We first started with analyzing what our industry standard of care had to say about specialty drying systems. And what we learned was that with dehumidification, there really isn't a lot of differentiation in the S500. Really, dehumidification is just spoken about as humidity control. It's spoken about very generically. It's not really, given us any real dive into the detail unless you go to the appendix. In Appendix B, there is some differentiation where we start talking about the difference between LGR dehumidification and desiccant dehumidification. In airflow, there's some discussion about differentiation with specialty systems. We do have some discussion about using systems to dry interstitial spaces. It talks about filtration considerations with those inter-air drying systems. It also talks about how necessary it is to do this when moisture is present in those cavities. By the way, quick shout out to Jamie for being the first person to drop a question into the Q&A. Thank you very, very much, Jamie. We'll make sure that is the first question we address in the Q&A session at the end of today's presentation. Then we also talked about filtration devices and how those were represented in the S500. Filtration devices has been a recent change in the S500 standard of care. It's become a bit more significant in the trigger language associated with their use. Generally speaking, filtration devices are a part of the standard of care when there are indications that warrant the use of particulate control during drying. And we talked a little bit about the language in the S500 that specifically addressed their use. Kind of moving into the details of that episode, we broke down the difference between LGR or refrigerant dehumidification and desiccant dehumidification. Our industry in general has really strayed away from a good, solid understanding of the difference between these two technologies and just the value that desiccant dehumidifiers bring. There is a very, very substantial benefit to desiccant dehumidifiers, in particular in specialty drying applications. And the primary reason for that is the technological difference between the two. A refrigerant dehumidifier is basically like a sponge. It does a really good job of soaking up bulk water. And just like a sponge, you can wring that sponge out and then put it back in the puddle and soak up a bunch of water, then wring that sponge out, put it back in the puddle of water, and over and over and over again. And when the water is like a puddle in your drying process, it's bulk water, a lot of water, high evaporation. It's a beautiful technology for that because it keeps up with really high rates of evaporation and keeps them in check and under control so you can control that environment and prevent further damage from occurring. The limit with the refrigerant dehumidifier is that if you take a really big sponge and you put that down onto a single drop of water sitting on your countertop, you can't wring that drop of water out again, right? And you're not going to make that sponge dry enough to really pick up really, really minute amounts of moisture like you need to do in a specialty drying application. A desiccant is very different technologically. A desiccant dehumidifier is like a moisture magnet. If there is a single grain of water on that counter and you pass that desiccant material over that grain of water, it will attract to that desiccant material. And once reactivated, that desiccant can be used to do that over and over and over again, right? So that's the difference technologically. A desiccant doesn't really have a bottom end, and a refrigerant doesn't really have a top end. So they're kind of opposite ends of the spectrum from that perspective. And when your goal is to take a controlled environment with reasonable drying conditions and make it an exceptionally low vapor pressure for elevated drying conditions, the desiccant is your wheelhouse. That is the technology that's going to take you there. So we got kind of deep into that technology and understanding that difference. The key takeaway was just that benefit of the desiccant dehumidifiers, really excelling in the low end of humidity performance. They're not very practical in high evaporation environments. And that's an important call out. I'm not saying that desiccants are the best dehumidifier in all cases. For your general humidity control, especially low grain refrigerants excel. But when you're trying to create an exceptionally low humidity where you have problem drying areas, that's where they excel. We then moved into air movers and talked about the difference in technology with air movers. We kind of put this down into a few different buckets, talking about the airflow they produce, cubic feet per minute or CFM, the force they produce that air with to overcome resistance, something we call static pressure, and last but not least, their power efficiency. We took a look at that in terms of amp draw or amp consumption, if you will. Really, it's watt consumption, but since we generally use 110 as a standard, we just took a look at it from the perspective of amp draw. We then relayed that into this graph so that we could take a look at the varied mix of performance across these specifications for different types of drying systems. Here, the lesson learned and the takeaway was that an air mover that's really good for CFM and really good for pressure is generally not great for power consumption. Right? If I want high flow and high static, it takes a lot of power to do that. And that's the reason why we have so many types of air movers in our industry. Some are really good at power control. Some are really good at airflow. Some are really good at pressure. And some are really good at pressure and flow, but they're horrible on power consumption because they're really good at both. And that's the reason why we have so many specialty systems. The way I kind of categorize this is the general carpet dryers were like the cross trainer shoe of air movers. They're okay at airflow. They're okay at static pressure, but not super exceptional at power consumption for that reason. We kind of applied that across the board as we went through that discussion with different types of air movers. The key takeaway from that is that your axials are generally the best at flow, and your inter-air drying systems are generally the best at pressure. And one example that I gave in that, you notice that bouncer blower there that's second from the bottom. These are the air movers that we generally use to positively pressurize the transition area between hardwood floors so we can force air beneath them. They generally blow at about 7 inches of static pressure. I gave an example to that's the static pressure that you would see in a bouncer, those big castles that you inflate at the fair that kids jump around on. At 7 inches of static pressure, what I inflate, you can stand on. That's a lot of static pressure. A true inter-air drying system, the very bottom of the chart, has a static pressure of 30 inches of static pressure. So just kind of relate that to some of these specialty drying scenarios where we're trying to pull air up between hardwood flooring boards or force air through insulated wall cavities. When you connect these two, air will move. All right. Either that or the cavity will inflate, one of the two. And both are entirely possible depending on the construction. So that was the kind of the walk into air movement and air movement strategies. We got very specific in this episode with hardwood floors, by the way. One key takeaway that I took from that episode that I want to share with you today is that these drying mats that we use on hardwood floors are very often used wrong. Right. The example that I'm putting here on screen for you with the kind of yellowish or the whitish shaded areas represent the mats. In the background of that, you can see the direction of the boards. Notice how my mats are installed perpendicular to the boards. There is a gap between every mat, and the gaps are longer in the direction of the boards and shorter perpendicular to the boards. This is the right way to install these mats. And if this doesn't make sense or this is not how you're installing these mats, you need to watch that episode because you're not getting the full benefit out of that mat system. The goal with those mats is to create a vacuum that draws air up underneath the mats between the installation joints. Right, the tongue and groove joint between those boards. That creates a negative pressure under the mat beneath the boards. The airflow is then generated as air migrates to that area beneath the mat, and the makeup air goes down between the boards. Right, there has to be an area around those mats for the makeup air to go down between the boards. Otherwise, nothing's going to come up underneath the mat. Right, you're just going to create a vacuum lock. And you're just going to put a negative pressure beneath the floor that generates very, very little airflow if you don't allow for that makeup air. All right. So the makeup air is going to be more significant along the lengths of the board. That's why the gap's going to be longer there. It's going to be less perpendicular to the boards because of the direction the flutes travel under the boards. All right. So that's the logic behind the reason for that installation. Key takeaway there. Then last but not least, and I'm spending a lot of time on this episode, but it was a powerful one. We talked about filtration and the installation for air scrubbing. We talked about the installation of these devices is generally best done with a little bit of lay flat ducting, right? The intake being in one end of your chamber and the exhaust being at the opposite end of your chamber. In a large chamber where more than one air filtration device is needed, doing that a couple of times. The reason that this is the best and most ideal installation methodology is because this forces an exchange right? What we're doing is we're causing air to move from the exhaust end of that lay flat ducting back towards the intake where our air filtration device is installed. If I just drop one of these in the middle of the room, I generally don't get the type of particulate control that I will as if I use the lay flat ducting and force an air exchange between the two extreme ends of the space within which I'm trying to control particulate. So really key takeaway from that discussion, I'm summarizing it. And again, we get into more detail within that episode. Episode 7, we took a little bit higher look at restoration projects, and we talked a little bit about maximizing efficiency in the project plan. And then I translated that not only to efficiency, but profitability, right? So let's take a look at some of the key lessons that we walked away from on that particular episode. We took a look at the S500 and really first started out by just understanding how important it was to have a drying plan and have a work plan for putting that drying plan into effect. I'm not going to spend a lot of time reviewing this concept other than understanding that the S500 makes it a standard of care item to have these plans in place. They don't necessarily have to be unique for each drying project. You can have a standard drying plan that generally fits most drying projects and then modify that plan as necessary for specialty situations in that particular project, especially as the S500 calls out, when there are limitations, complexities, complications, and conflicts. More to come on that topic in just a moment. From there, we took a look at a flow chart that helps us manage that plan. This is a flow chart that I've walked through a couple of times here at Technically Speaking. It's a flow chart that I've used in training for water damage restoration since about 2000, 2001, somewhere in that area, with a few modifications along the way. What this chart does is it helps the technician or the project manager who is in a specific project understand that although this is my plan, what the plan does is it gives me the freedom to make the modifications I need to my approach to that specific project, to adapt to the project and document why particular steps were taken along the way. It brings logic into the process, it mitigates risk exposure on the project, and it mitigates the overall cost while maximizing profitability. And I'll show you kind of an illustration of that here in just a moment. Generally speaking, what this does is it forces me as a technician to first make my assessment for what is actually affected within the space, and then tailor my restoration based on a triage assessment. That triage assessment looking at contamination, damage, and cost. Those are the three main buckets based on everything that is affected that drives my decision for what to restore and what to replace. Then once I know what to restore, to measure the amount of moisture in those restorable materials, document that, and deploy the appropriate drying strategy, right? Based on class of water, the resources that I have available, the environmental conditions, etc. Key to the process is then monitoring for progress and assessing where did my drying plan effectively force progress, where did it not effectively force progress, and understanding and realizing there is no such thing as perfect. That first day, my assessment is going to be a collection of as much information as I can possibly gather to determine what the best approach should be for this particular project. Then I'm going to deploy that approach. But because it is impossible to know every single variable in that project, for example, how many layers of paint are on the wall, or how many times that sheetrock has been wet, and how that's changed the nature of the sheetrock, what occupants are going to do to my drying equipment when I'm not there. These are all things that I'm not going to fully understand the impact of initially. But 24 hours later, I'll see the evidence for it, right? And at that point, if there is progress, great, we continue. If there isn't progress, we adjust, we change, right? And we use the lack of progress as the evidence and proof for the reason of the change and document accordingly. So it's a critical process that really drives me to ensure that in every restoration circumstance, I am deploying the process that is most appropriate for that particular project. Now, when we do that, this is the end result. Okay, and I want to kind of walk through, because this is a very, very key takeaway from this year. And I'm going to drive this by asking you a question. Would you rather have 10% of $10,000 or 40% of $1,500? Which would you rather have? right? Or 6,000, excuse me. Would you rather have 10% of $10,000 or 40% of $6,000? Obviously, I would rather have the 40% of the $6,000 because that's more profit coming into my organization. It's also a far less complex project to collect on, right? Think about your accounts receivable. When 90 to 95% of your project is demolition and reconstruction, the accounts receivable and collection process can be far more complicated. When 90% of your accounts receivable is mitigation and drying, your accounts receivable are generally much more manageable in terms of the time to payment and the complexity of that collection of payment. So what this does is it drives us to understand that by applying the process on the previous slide, if I'm only removing or demoing what I have documented evidence should be demoed or removed, and I dry the rest, we become more profitable, we mitigate the accounts receivable, the overall duration of the drying project and the restoration project is shorter. Everybody wins in that process, right? When we can drive towards that more logic-based decision-making process. And the final takeaway is don't remove something in a water damage project just because that's what you did last time. And that was kind of my key message that we were trying to drive in that episode. Don't do it because that's what you used to do 20 years ago. Don't do it because that's what you did last time. Do it because something on this project is documentable that says it needs to be done this time. Right? Find the evidence for it and document the other evidence. Otherwise, restore it, dry it, right? So episode 8, we shifted gears. As I said, more on this to come in a moment. Limitations, complications, complexities, conflicts. The most underused part of the S500 is section 11, LCCC. If you've never read it, then I'm going to give you an assignment. You need to read this section of the S500. It's a wonderful tool for risk management. So let's take a quick review of some of the key lessons learned from that episode. First of all, why is it important to understand this section of the S500? Because it helps you assess and quantify the risk level with specific decisions on a project. It can simplify this process of determining solutions, give you objective decisions based on that risk level, which overall is risk management and risk exposure 101. It also gives you the ability to document those issues properly. And in a nutshell, basically what LCCC does is it puts issues on a project into one of 4 buckets. And you ask 2 questions to decide what bucket it's in. The first question that you need to ask is, are you aware of the issue before the project starts? Yes or no. The second question is does the resolution to this issue afford me the opportunity to comply with the S500? Yes or no, right? Now, if you answer yes to the first question, lower risk. If you answer yes to the second question, lower risk. If you answer no to either of those questions, higher risk. And what you're trying to avoid is no to both questions, right? Because that's where ultimately the only way that you can really mitigate your risk exposure is to document that there is a conflict, stop work, document the stoppage of work and the source of that conflict, and do not proceed unless the conflict is properly resolved. All right. So that was kind of the sum of the LCCC section. And again, what that does in the S500 is it gives us an opportunity to categorize these and point to the S500 as the reason why we're taking the actions that we are. If they're complexities, pretty straightforward, right? You can still comply with the S500 and you're still aware of it before the project starts. It just makes it potentially a little more expensive, right? We just document that. If you can still comply with the S500, you're just not aware at the project start, it develops during the project, then we got a change order, right? Or we have communication that says, hey, this new piece of information has surfaced from the project. It's going to have an impact on the cost of the project, but we are proceeding and we're proceeding with this methodology, right? If somebody comes to you and says, no, I changed my mind, now you don't have the ability to open up that wall assembly. That's a limitation, right? So again, with each of these, it gives us the ability to understand what are the effective documentation tools, how do we communicate, how do we manage that to ensure that we are mitigating our risk exposure as restoration professionals to the best of our ability. All right, so that was the episode on LCCC. Now we get into the final quarter of the year. Episode 9, we got into atmospheric and moisture readings. A couple of key takeaways with atmospheric and moisture readings, 2 in particular that I really want to stress. One is there are 2 different mindsets to moisture inspection, if you will, or moisture measurement. One is inspection, the other is monitoring. And it is absolutely critical that you think of these differently. Inspection is what you do like a bookend at the front of the job, at the end of the job, or at the end of the drying process in an area of the job. Inspection is highly detailed. I'm going to use my meter in more places than I care to document. It's going to be all over the place. I'm tracking from the source and out from the source, migration three-dimensionally. I'm finding where the water started, where the water stopped, how deep into the assembly the water is penetrated. I'm documenting the assembly components that are impacted, but it's just a picture, a high-resolution picture of that particular point in time. From that inspection, I then establish monitoring points. I'm not going to monitor every location that I inspected. I'm going to determine where those monitoring points need to be based on the assemblies that are being dried, where my concerns are for the slower drying rates, where there's built up assemblies and complexity. I may have more of those monitoring points. Where it's simpler or more porous, I may have fewer. It's completely at the discretion of the restorer. However, there should be at least one monitoring point in each of the components that are affected, right? At least one. Monitoring, as opposed to inspection, however, is not highly detailed. Monitoring is highly consistent. Same meter, same setting, same location, same depth, same method of documentation, even the angle the meter is being held at, especially with non-invasive meters, all of that needs to be consistent. Because what is critical or paramount is your determination of whether or not the material is drying. That's the essence of what makes us professional restoration contractors, is our ability to take what nature would do on its own to slowly acclimate, manipulate that process, leverage that process, expedite that process, and make it faster, right? That's where our core expertise is making that dry happen faster. So we need to be able to document that. Right? We need, of all things, we need to be able to document that. And if you don't use the same meter on the same setting in the same spot on the same piece of paper or the same app or the same documentation system, then you don't know if the material is drying. And I give a moment of silence there intentionally for dramatic effect. You don't know if it's drying if that doesn't happen. So that's the difference between inspection and monitoring. We got into some methodologies to control for consistency. I'm not going to get real deep into that, but again, we got into that within the episode. We also talked a little bit about atmospheric readings and monitoring, and I shared with you several takeaways here, but one of the key takeaways that I'll recap here for you today, what makes atmospheric monitoring confusing and kind of just throws the user into information overload is when you look at too much of it at once. Right. When I throw these numbers up on the screen, if you don't zero in on those two areas I've highlighted in yellow and know why I've highlighted those in yellow, then this just becomes data overload, right? It's just a bunch of numbers. The reason I've highlighted those two on screen is because the real value in atmospheric readings is comparison. If you're not making a comparison, the numbers by themselves really don't mean anything. Right? So let's take a look at that affected column on the upper left. Day one start, 70 degrees, 78% relative humidity, and 85 grains. That's what that first reading was. Now I've highlighted all of the grains per pound for that affected area there, but 85 was the grains per pound initially. Now, by itself, that doesn't mean a lot. 78 degrees, or 70 degrees rather, 78% and 85 grains. What does 85 grains mean? Really not a lot. If you want to be specific, it's 85 7/1000ths of a pound of water in every 14 cubic feet of air processed by a dehumidifier, right? What does that mean? Nothing other than sounding kind of fancy, right? The only reason that 85 is important to me is because I'm going to compare it to other readings on the chart. On the far right-hand side, I see 106. Those are the grains per pound at the surface of a building material that I'm drying. All of a sudden, now the 85 becomes important to me. If I have 106 grains per pound at the surface where I'm drying, but the air above it is 85, you don't have nearly enough airflow, right? If you had enough airflow, it'd be 85 grains per pound at the surface of that material too. That material is responding to 106 grains per pound, not to 85. your 85 grains per pound is useless at that point. It's not doing anything for you. And 85 would be better than 106 at the surface. So what this does is it tells me that I've failed my air mover installation. I need to get better with my air mover installation. And notice how I got that by making a comparison between two readings, singling into one atmospheric value, in this case, grains per pound, and then making a comparison. And that was the lesson learned with atmospherics. Kind of the key takeaway is if psychrometric readings and atmospheric readings look confusing to you, the first thing you need to do is understand that it's all about comparisons. It's not about a single reading. It's about comparisons. It could be comparisons of today versus yesterday. It could be comparisons of this room versus that room. It could be a comparison of this room versus the dehumidifier that's in this room, or this room versus outside, but they're comparisons. That's what yields the value in atmospheric readings. All right, 2 episodes left to recap, and I'm almost out of time, so I'm going to speed up so we can get to the Q&A. We will run over for the Q&A, by the way. When we hit the top of the hour, I'm going to keep open for at least a half an hour to go through Q&A, so anybody who wants to stick through for that open town hall, we're going to spend lots of time doing it. So episode 10, we talked about categories of water. We got into a discussion of what the S500 has to say about categories, their definitions, restoration procedures, et cetera, et cetera. We then got into the impact of source, migration, time, and temperature on category. The primary and key takeaway as we went through this discussion on category was the understanding that the definition of category 1 is not that you could take a cup, pick up, a cup of water off the floor and drink it, right? That's not the purpose of category 1. That's not the reality of category 1. And that's not the reality of any water damage restoration project. And that does not mean that there is no such thing as category 1. So we spent some time kind of unpacking that and understanding that there are several situations and circumstances where category 1 does indeed exist. And the opportunity for drying materials absolutely exists. That we then got into a variety of discussion about the examples of category 2, the reason why category 2 is important, and kind of the sliding scale for procedures based on the severity of that category 2 is kind of the gray area between category 1 and category 3. And then finally, we concluded with a deep discussion on the importance and the urgency of understanding health and safety in category 3 and why category 3 is what it is and how critical it is that we understand that those example sources for category 3, they contain potential pathogens, things that can cause chronic disease, right? That can permanently impact, the health, quality, or length of a human life. And that's the reason why those procedures are so critical for category 3. And then I kind of wrapped the session up with understanding how important it is to cite those sources from the S500, especially with property managers, non-owner occupants, in those situations where sometimes it can be tough to sell a category 3 remediation ahead of the drying and restoration effort, especially when time and cost are taking precedence over proper procedure and health. Okay. Last but not least, we got into thermal imaging. We talked a little bit about this in just this last month's episode. The key takeaway with thermal imaging is that it's a very useful technology that's permissive in the S500. It's not required, but there are circumstances where the restorer really can and may use thermal imaging to supplement the inspection and evaluation process. The S500 does, however, say that it is standard of care. You should ensure that you're using a moisture meter to verify anything a thermal imaging camera does reveal as a potential area of interest within the space. We got specifically into the technology. We talked about what thermal imaging cameras actually detect versus what they display. They detect the emission of infrared light. They display a false color representation of that thermal emission. We then got into some of the phenomena that impact that thermal emission. Evaporative cooling, thermal capacity, thermal bridging. These are the reasons why a thermal imaging camera can be useful in the assessment of areas of potential moisture in a water damaged environment. We also got into all the reasons why they give you false news, right? All the other things that impact the thermal emission from a surface. Airflow and drafts, missing insulation, thermal bridging, HVAC and electrical assemblies, surface reflections. So we took a deep dive into each of these. We even uploaded a white paper So for those that were in attendance, we uploaded a white paper so that you had access to all of the background technical data that stood up that presentation. As we get into the Q&A today, by the way, if you want to go back and review that episode and you'd like the white paper that I produced to accompany it, please send me an email and I will email that white paper to you. And that was season 4. All right. That was a lot. We covered a lot in season 4. So with that said, a couple quick announcements here, and then we're going to get into the town hall Q&A session. Looks like we've got a number of questions that have been loaded up. Thank you so much for doing that. And again, we're going to extend the time here a bit for anybody who wants to be here for the Q&A. Stick with us as soon as I get through these announcements. First announcement is that we are going to continue, technically speaking, into 2026 with season 5. I'm super excited to bring this next season around. I do have a favor to ask. I'd like to know what you want covered in 2026. My email's on screen, brburton@cotality.com. Please shoot me an email and tell me what you would like me to spend the time researching, to drum up some experts if I don't have that expertise personally, who you would like to see me interview, or what topics you would like to see addressed with Technically Speaking in 2026. What I already have in the docket is I do plan to cover wildfire restoration. Like I said, we now have a technical guide that was just been released today. If you don't have a copy of that or haven't seen it yet, and you'd like a copy, send me an email at brburton@cotality.com, and I will reply with a copy of that document. I also plan on discussing AI as we go into 2026. I personally have spent a lot of time working with AI through the course of 2025. There are some upsides, some downsides, some applications, and some absolute must avoids with AI. So I'm going to talk a lot about that in an episode in early 2026. So we'll bring that as well. But what else would you like to see me cover? And if you'd like to go back and look at any of the episodes that I recapped today, go to www.nextgearsolutions.com/webinars. There is a filter on there. If you set the filter to IICRC CEC webinars, then you'll see just the webinars that I've produced, which will be not only the technical speaking series, but any other webinar that I've done under Cotality, where we have gotten approval for CECs. There's a handful of other webinars that I've also done. So take a look at that at nextgearsolutions.com. Last but not least, my final announcement, the early bird discount for Interconnect has expired. However, you can still get the Technically Speaking discount of 15%. You also throw me a bone if you register for Interconnect and you put in Technically Speaking as your discount code. Not only do you save some money in the registration, but you throw a little bit of a feather in my cap for being the one that sent you there. So please register for Interconnect and use the Technically Speaking discount and share it with your friends. All right. That's it for the presentation. Now let's get to the Q&A. All right, give me just a minute here. I'm going to go ahead and get my Q&A screen refreshed. Take me just a moment to get that open. And here we go. First question